Hello guys, this is my CSET 3600 presentation on test-driven development, UML modeling, and software security. And this presentation is brought to you by Zachary Hammersmith, that is me. And before we get started, just want to go over what this presentation is going to contain. So with each of these aspects, I'm going to be explaining what each of them means in some detail, going over each and every aspect within these software aspects, and we'll be diving right in and explaining how each would be applied to one another and how every one of them can be integrated into the concept of software development. And I will also show you examples of some of them and a case study as well. So let's get started. So what is test-driven development? So test-driven development, or TDD as an acronym, is a method that is used for building and running code in a testing environment before it can be placed into a real-world application. So basically, in that sense, it is just you make your code, and once you made your code, you looked at it, you put it through a test, and then you make sure it passes or up to your standards. And if the code does not pass, what will happen is it will go through the creation process again, and then it will be ran again for testing until it passes. So in the case that it does pass, what will happen there is the code will be able to be released, but also not before the code will be in some sort of developmental stage. And what I mean by that is that the code will be put through some updates. And with these updates, these are just small or even large improvements upon the code that was originally released. And why would you need to do that? Well, simply just because code can become more outdated as new technology is produced. And so you would want to try to keep up with that trend by making more improvements and fine tuning to your code to make sure that it's up to date with the latest technology, and also providing a lot more convenient options for your users. And as I just explained, here are the steps of TDD, or test-driven development, as they follow. So what you do first is you create the test, you run it, and then you can rewrite the test until it passes. And as I explained before, if it passes, then we move on to the refactor stage, which is just basically a combined definition of updating your code and everything that comes with that. And then, yeah, if it fails, it goes through the last two stages. So we're going to dive into a little more detail about these steps. So let's get right to it. So what we have first off is the create test, and this is our first step in the TDD process. So this simply is just the test or the step that you basically create the test and the code for which you want to create your product on. And what you want to have ideally for testing it is that you should be able to make it simple and it should be focused on a specific or large aspect of the code. So what we mean by that is we want we want the code to be as simple as we want the code to be as easy and understandable for everyone else on the team and especially yourself, the one who is developing and making the code, as possible, and while also keeping the fact that it's focusing on a significant or a large part of the code. So we'll take, for example, you have just a basic you have a basic Java program that focuses on developing a system for getting someone's like user ID and password. So what would you do? So what would you do? You would basically like create a simple test file that has like a simple name that meets the verifications with the username and password. It meets all the verifications and not making it completely complex, like you're putting 50 words in username, 50 words in the password. Just something that meets just at the standards and that it can still pass and run through the code easily. So that is what pretty much you should be going for when considering developing the test phase. So once you do that, once you get your code and test created, what you'll do next is basically just run the test. And this is going to be the second step in your TDD process. So when running the test, you can either have a fail or pass result from it. So when the test fails, the code can be reverted back to the first stage, which is your create the test stage, to be reevaluated and written until it passes the test. And if by chance it passes, then it will be looked at for any sort of improvements that it may need before being released and onto the refactor step. So next is just basically just a branch of what was on the second one, which is just rewrite the code until it passes. So as I said, it just involves assessing the code and just detecting where the problem is. And once the code, or once a problem with the code is found, it will hopefully then be edited and tested until it meets the right specifications to qualify as a pass. So whether that would be like a problem with like a slight integer variable problem, something like that, any sort of minor syntax problem, that can be fixed up easily. But if it has something to do with anything runtime or logic, those codes typically take, or these malfunctions typically take a little bit longer to figure out. And so it's always a good idea to take an efficient amount of time spending on your analyzing your code. And so, as I said, when the product will pass and it gets officiated to be released, you can then move on to the refactor stage. And so what this is after even passing the code, getting released, you can then modify this code to suit the needs of the programmer and the technology around it as well. And by also updating it, you would also have to cycle it back through the past three other stages as well. And the reason that is because you're implementing new code whether it's going to be big or small. Like it's still new code. It's still different from the original code that you've developed, and as such, that still needs to go through the testing phase. And if your code happens to not like pass the original way it was, like that still has to be cycled through those last two stages. That create test and run test, those have to be cycled through again. And so whether it would be like any sort of problem with like the test itself, it had to be modified. Like it, if it still needs to like be like modified or something like that, like the test itself to kind of suit the needs of the newly developed code, then then so be it. If it still meets the qualifications of being simple, yet it targets a large aspect of the code, and it passes, then it is just fine. Okay. So why do we use test-driven development? So why we use test-driven development? It's because it's an effective and preventable way of reducing bugs and code malfunctions in the production process. And it also can improve the quality of work done to the code. So test-driven development gives us a more structured and organized way of developing and improving and testing our code as in pretty much like a very time efficient manner. So yeah, like instead of just making code and developing it out of the blue, where it most likely won't have organization, test driven development gives us pretty much a structured idea of how we as developers should be looking at our priorities as to what is important first and what is pretty much like our least important priority in making our code, pretty much. And most of the time, we don't have structured like uh, for our development process. That can open up the risk of developing any sort of bad bugs that could just intrude upon our code, or it could cause our code to crash altogether, which that is basically just the worst case scenario when it comes down to it. So we want to prevent those two things from happening, and test driven development is pretty much the process that kind of prevents us from having to deal with those things, albeit on a very lesser and riskier scale. So moving on, we have our UML modeling. So we're going to be explaining what is UML modeling. So this is a modeling language in which a set of diagrams is used to help visualize, construct, and document the software production process. So this is a little more of a visual modeling language, and it kind of gives users like a better idea of how like their classes, their tables are going to be organized and structured, and it gives places where variables will be placed. Like I said, they can either be placed in SQL tables as examples below, or they can just simply be put in like Java, Python classes. But as I said, these are UML modeling is pretty much giving you an idea of how you want to structure your code. Keyword is pretty much idea. So as I said, these two examples right here are a little bit different from each other. These are some of these, well, these are examples that I have made during some of my assignments here this semester in particular. So I'm going to be going over kind of like how I structured all these UML diagrams and pretty much what they mean. So without further ado, we'll move on to example 1. All right, so right off the bat, we're going to be starting off with an example in which this is pretty much for an SQL UML diagram. This is for structuring SQL tables. As you can see, the main entry that all of them stem from is the cruise ship entry right here. Every one of them branches off and comes off right here because as you can look at the IDs right here, the VID obviously traces from the visited ports. The DID derives off of the departed ports. Both these two, departed and visual, are one-way relationships towards the cruise ship right here. Moving a little further down, we've got this special little one right here. This is a three-way relationship right here. The traveler's feedback. And so this connects the traveler's entry right here on your far left over onto the cruise ship main entry right here. And this is pretty much done by the traveler's feedback holding 3 of the entries as you see in here. The T obviously is connected to the traveler's ID. You've got the S right here. That one is actually connected to the cruise ship right here. And the E is actually connected to the cruise employees, which I forgot to mention was also connected to the traveler's feedback 3-way relationship. So yeah, basically all these are either connected through one way or connected through a three-way relationship here. So this is just an example in SQL formation of how a UML diagram would be implemented. So we'll move on to example 2, which is something a little more relatable to this class, which is the Java class UML diagram here. This one in particular was one of the ones I created for one of my assignments. So as you can see, our superclass up here is the animal class right here, which you got your age integer, your color character, your pet type character, and all the accessors that go with each of these variables, as well as just the animal superclass itself. And so this is pretty much daisy chained right into the pet class, which is just basically a modification of the animal class. Everything, a lot of the variables and everything derive off the pet class, mind you. But what the pet class sets itself up for is to make any sort of modifications for any particular case that it wants to make. So as you can see, the pet class, it's a little bit almost identical to it, except for the fact that they include set methods or mutator methods in their class here. So basically, yeah, you guys know what set methods are. They change the they change a particular variable of the class or make some sort of restrictions towards it that someone may need to make. And lastly, we got our dog class right here, which right here is just another specification of your pet class over here. but it is suited for only dogs. So as we go down the line, you can see the relationship being made. The animal class is the above all superclass, which umbrellas both the pet and dog class. And the pet class right here is derived to the dog class over here. So as you can see in this diagram, it can both work for Java, even something like Python. Anything that is pretty much object oriented here would pretty much be worked on for. So this is pretty much an example of basically an object oriented UML diagram here. So why do we use UML modeling? So in particular, for object oriented programming, this often gives uh, developers pretty much an idea on how to design their software in pretty much a graphical notation for basically representing the software project. There's also the added benefits of better team communication, as well as a wider variety of potential designs for it too. Okay. So when you're so as I pretty much like said a couple of slides ago, UML modeling is for rolling the ball on the idea of how to design a software. So as I said before, so yeah, it's not to give a design of the code. It is to structure your code in a way that it will give you an idea of how to design your code and test it. So again, this is not for flat out designing your code and testing. So we'll move on to how we can integrate it into test-driven development. So UML is a modeling structure that gives many approaches to the design of a structure. And integrating it can basically be done through creating an approach to the code and test design, as we stated before. So again, we'll repeat. UML can be implemented into test-driven development, but it's not necessarily a necessity, and it's not the only way you can develop code. But it is suggested to be one of the more popular and better ways to create a modeling structure for your code. So that's pretty much basically why we would maybe want to get an idea of why we want to implement UML into test-driven development. Basically for the idea of getting an approach on code and test design. So moving on to software security here. So my definition of software security is the protection of a computer's identity and intangible assets from potential threats that can harm the computer or assets. So whether that be just any sort of computer hackers, any sort of viruses, any sort of that has to deal with the threat of your computer's well-being, can be pretty much tied to securing your software here. So the assets too. What I mean by assets, I use it in a couple lines of my definition. So as you can see below, assets is just basically a combined term for basically a system's information, files, programs, memory storage, etc. anything the computer or your or whatever you put into your computer, like I said, data, information, files, programs, anything that you create that is privatized to your desktop, mobile device, whatever you have, is considered assets. So then we'll move on to why we use software security here. So providing security for your software can allow you to gain control of who is accessing your assets, who is tracking, or who is trying to attack your system, and who is enabled to certain assets. So preventing any sort of loss of control because of someone trying to override your system, as an example here, is probably is definitely one of the biggest reasons why you want to utilize software security. And probably like a good everyday example for anybody who just uses any old generic computer or standard computer, I would say, would be firewall. Firewall is probably one of the examples that can come to my head. It's used pretty much almost on every Windows, Mac, and everything like that computer. And a little bit of description of what that does is it just filters out any sort of potentially harmful or potentially unnecessary pieces of data that could stream through your computer and could potentially leak a virus into it or could potentially slow down your computer too. So just giving a little bit of an example of kind of what a basic software security can do, but there's obviously like other add-ons that are out there. I mean, there's complex, or there are probably like stronger firewalls out. There's stronger firewalls out there for larger networks. There's also antivirus software, but won't cover that either. But that's one to give like a basic example of a software security. So we'll go over like any sort of potential threats to the software. So some of these potential threats include hackers, viruses, aka something like a Trojan horse, any sort of computer worms that can get in. And mind you that these can come from legitimately anywhere on the computer. Anything that is basically on the computer can leak any sort of potential to release some sort of deadly threat to your computer. Whether it be your email, whether it be a website you're visiting too. I mean, and even if you're offline, you don't have internet, that doesn't stop any sort of potential threats that could tap into your computer, whether it be majorly or flat out destroying your computer. So a little bit more examples of pretty much where threats and sort of just unleaked, privatized information can come from is pretty much social media. Social media basically allows a user to share their information publicly with everyone on that platform, while pretty much it is like it's very sociable and pretty much seemingly harmless on the outside to share social media. People need to keep in mind that anything that you leak on that social media platform pretty much opens up the likelihood of that information getting stolen. And if it's not secured correctly, though. So taking precautions like setting up a password when people log in, or when you're trying to privatize your information to only yourself. So, like, say, Facebook, you can do that on Facebook. Those are ways that you can pretty much protect yourself and your identity on Facebook. And certain mobile applications can also carry potentially threatening viruses on your mobile devices as well. So, like, whether it be like a virus, or even sometimes, like, if a mobile application just slows down or just corrupts your system just a bit, like, it can still be a threat to your mobile device's software. And lastly we got cloud computing. Reason why we list cloud computing is it's still a gray area when it comes to security, and this is due to cloud computing just still having unknown and untrustworthy aspects towards it. So next, we're just going to analyze software security, break it down a bit, and see what qualifies. So security modeling helps establish a software's policies, objectives, and requirements to meet for the team and the software. And also, to add on to that, it also helps for making the requirements for the interface of the software, the background code for the software, and the testing environment as well. And measuring the design basically just shows the threat risk that a software could potentially have if it were to be released, the asset security, and the system security too. So it's good to measure the design's threat risk, the security of its assets, and the system before releasing it. Because nobody wants to release a product that has a high risk of getting a virus or being tapped into by a hacker or having their privatized information not secured. So next, we're going to talk about correctness checks, which all they do is they look up software activities, whether they be normal or abnormal, in which this allows one person to collect or analyze data in a secure and from a secure manner, pretty much. So correctness checks basically just look over and analyze data just to check for like any sort of unusual activity that may indicate that something is trying to get into the system. And by checking it, they can take steps to pretty much prevent that sort of threat from coming into that system and corrupting it. So next, we're actually going to take a look at an example that does kind of involve some of these analyzing aspects of software security. So this is a case study from the ransomware aftershock in the city of Baltimore. And to summarize this, it basically goes that the city of Baltimore's computer systems experienced a hacking situation during May of 2019. What happened was hackers broke into their system and they basically got a hold of some data files and they encrypted them and called for a ransom in exchange for the IT department's encryption keys. So they were basically at a bit of a standstill for a bit with these hackers, the government in Baltimore. So the action that they took, which was by the mayor, Bernard Young, and the IT department, they came to a conclusion that they would not give in to the demands of the hackers, which was to pay an absurd amount of money towards them in exchange for taking their system hostage. And so, kind of their alternative method towards it is the IT department decided to recreate the city's computer systems. So, recreate it entirely. They completely made something completely new out of it. And this estimated rebuild and cost from the attack basically was around $18 million in damages. And in 2019, the city's auditor had also told officials that IT performance data had been lost from the attack. Since there were no precautions to back up the data, the auditor was unable to do anything with the data from the IT department. So they weren't really able to get back that lost data from that situation back in May. And so that cost them a whole bunch of time and money to just for that. So we're going to look at what precautions could have been taken and how the outcome could have gone a lot better if they had taken these precautions before. So one of my suggestions was that the department should have gotten into the practice of backing up the data either through a cloud-based platform or an external hard drive. So in that case, that when even if data from like that March or April of 2019, if they had backed up even before then, like a little more frequently, they could have saved some of their data instead of losing pretty much 100% of the data that was corrupted by those hackers. And also by using correctness checks, IT could have traced any abnormal activity outside or within the parameters of the system. And this concept of correctness checks could have also been applied to the auditor in the case that he could have more frequently asked for data collection and analysis from the IT department. That way he could check and make sure that the data he had, or the data that the IT was dishing out to them, would have been normal. And if he could have traced any sort of abnormal activities, he could have told the IT department, and IT department could have stopped the threat from even servicing on the system. So what we're going to talk about next is just the importance of test-driven development, UML, and software security in software development. We're kind of bundling them all together and wrapping them all up in why they are essential to developing software. So when developing software, developers must be sure to take the necessary precautions when creating a design for their product. Using a UML model can help design the product. So TDD prevents an efficient and organized method for testing the product before release, and incorporating the software security into test-driven development can help make the product free from any potential hackers and viruses that may try to intrude in. So basically, yeah, UML can help develop the design of a product and can be implemented into test-driven development and help with that process out a little more. And then test-driven development can also have an implementation of software security in mind when they're testing not only if the code functions, but also if the code can be secure and have a smaller potential of contracting any sort of potential threats if one were to use that software. So the basic idea is you want to develop a visual, steady, but also time efficient, cost efficient manner of developing your test while also keeping in mind the software security precautions that either you or some sort of standards have set aside, and making sure the final product does reach those principles that you have set. And here's the outside references that I used right here. So as you can see, this is where the case study is. The first one is some information to get me an idea on UML, some ideas on test-driven development, and that is pretty much it. And that pretty much wraps up my presentation. And yep, that's about it. So bye-bye.